Good afternoon everybody, myself Amandeep Kaur from GPCG Patiala, lecturer of IT, and today I am here to discuss with you a topic of internet and web technologies, that is internet security. First of all, what are our today's learning objectives? Let's have a look on that. First of all, clarify need for security. What are we trying to protect actually? Why do we need to make secure network? Then we would be identifying fundamental security objectives, review basic network attacks. What are the different type of attacks that can harm your network? Then we will classify the typical attackers. What are the various types of attackers that attack your network? Then we will examine the technical safeguards. What are the various type of, you can say, safeguards that you can employ in your network? Then explore firewall options. These are the topics that we will be discussing in today's lecture. First of all, what are the internet security needs? Why do we need to make the network secure? Why do we need? While non-technical publications are obsessed with the internet, technical publications are obsessed with security. Information view, marvelous technological advance in information dissemination with a major danger to pollute and destroy. Transaction view is major deterrent to e-commerce growth. So these are the internet security needs. First of all, we need to make technical publications secure. Then we need to make the information that is over the network to make that secure. Then we need to make transactions secure. For example, if we talk about ATMs, then we need to make secure those ATM transactions as well. Then what are the things that we need to protect by making internet security? First of all is data, then the resources, then reputation. In data that we can include information we keep on computers, product design, it may be financial records, or it may be personal data, that is the information of the employees. So these are the things. Apart from that, you can say lost time, lost sales, lost confidence. All these are also under data only. Then we have resources that we need to make secure. Unauthorized use of computer time and space. So there shouldn't be any unauthorized access to your computer systems or time and space. And there is another thing, that is reputation. It means misrepresentation, forgery and negative publicity. The data that you have kept in your computers, it shouldn't be misinterpreted and it shouldn't be forged, or there shouldn't be any negative publicity of your data that is residing on your systems. So what are the fundamental security objectives while talking in terms of network? There are 4 fundamental objectives of information security. First of all is confidentiality. It is protection from unauthorized persons. Then the second is integrity. It refers to the consistency of data. That means no unauthorized creation, alteration of, destruction of data is occurred. Then the next is availability. It ensures access to legitimate users. That means only the authorized persons will be able to access the data. Unauthorized person won't be accessing your data. Then last one is legitimate use. It means ensuring appropriate use by authorized users. It makes sure that even the authorized users are not making inappropriate use of your data. That means they are not using the data in any misuse. And the next is basic security attacks. What are the basic security attacks that we encounter in everyday life? First of all is intrusion, the next is denial of service, then next is information theft. Now what is intrusion basically? It is unauthorized access and use of your systems. When a person is unauthorized to access your computers, and if that person is accessing your system, that is known as intrusion. Then the next is denial of service attack, an attack which is aimed at preventing use of company computers. As its name implies, denial of service, that means your server or your systems will deny to provide you the service that they are meant for. That is known as denial of service. It is an attack which is aimed at preventing use of company computers, or you can say servers, or you can say any kind of software or hardware device which is in your organization. Examples are email bomb or flooding, internet worm, or you can call them that your systems will be disabled, rerouted or replaced services. They won't be providing the general services. They will provide you some other type of services which you are not intending to do so. And then the last one is information theft. It includes network taps, database access, hacking into sites to give out more information or to wrong parties. That means they will simply steal your information and they will give your information to wrong parties which can misuse them. Then the next type of attack is phishing. Most commonly, it is an email stating your account information needs updating. You may have seen in your Yahoo or Gmail accounts there are spam mails which ask you to give your personal information or your account number so that they can transfer a lot of money into your account. That is an example of phishing attack. You should watch for URLs that are numeric or different from the link you clicked on. Best thing to do is to type in the URL and check your account directly without following any links in the email. Many legitimate emails no longer contain a link. So this is phishing attack. Then the next are what are the technical safeguards that we can employ in your systems in order to make our network secure. Security services, there are 5 types of security services. First is authentication. It includes entity and data origin. Then the next is access control. It will control the access. That means it will prevent unauthorized access to your data. Then the next is confidentiality. It means disclosure or encryption of your data. Then the next is data integrity. It means value of your data items, or you can call it consistency of your data. Then the next is non-repudiation. It means falsely denying a transaction. These are the technical safeguards that you can employ in your systems. Then the next is security models. What are the basic security models that we can follow in our network? First of all is no security. It is basically not an option in a network environment, because in order to have a network you need to make it secure so that nobody can access your data in an unauthorized manner. Then the next is security through obscurity. It means don't tell anyone where your site is. It simply means you don't have to disclose that where is your site of network. Host security, enforce security on each host, progressively difficult to manage as number of hosts increase. So it is in this system you basically make the host secure. Then the next is network security. It controls the network's access to hosts and services, firewall, strong authentication and encryption. So basically it includes number of firewalls, strong authentication methods and encryption methods as well. Now what is firewall actually? The definition is hardware or software components, or you can call them hardware and software components, that restrict the access between a restricted network and the internet or between the networks. That is known as a firewall. Basically it works like a wall between your local area network and the outer network. So whenever there is a request from local area network to access something from outside, the firewall will scan that request, then only it will forward it. Similarly, whenever a request comes from outside network to inside network, then also firewall works in the same manner. It validates the request first of all, then only it transfers the request to the outer or inner network. Logically, it is the separator, restrictor and analyzer. Similarly, as I told you earlier, it is rarely a single object which restricts people to entering at a control point, prevents attackers from getting close to other defenses, that means host controls, and it restricts people to leaving at a controlled point. So basically it works like a controlled point where it validates or separates the traffic, it restricts the traffic, and similarly it analyzes the traffic as well, that what type of requests are coming from outside and what type of requests are going from inside. It checks all the requests that are coming from network. Now, what are the firewall capabilities in actual? There are numerous capabilities of a firewall. First of all, focus security decisions, single point to leverage control. Then the next is enforce security policy, which is minimize exceptions, log internet activity, it means analysis, limit exposure, it means separate sensitive areas of one network from another or outside world. Now, what are the firewall limitations? It cannot protect against malicious insiders, connections that don't go through it, new threats and viruses, scans for source and destination addresses and port numbers, not details of data. So, these are some limitations of a firewall. What are these basically? It cannot protect against the malicious insiders of a network. That means if a person is maliciously destroying our network from inside, it won't be able to detect that. Then numerous connections are there which will not be scanned by the firewall, and there are new threats which are not scanned by the firewall, and there are number of viruses also. So, these are limitations. Now, what are the types of firewalls that are available in today's market? First of all is simple traffic logging system. It is audit log file of files accessed. It means it keeps log of all the files that are being accessed over the network. It works like a index file, whatever type of information you will be accessing, or you can say that what type of files you will be accessing over the network, it will maintain the list of all those files. Then site usage, demand hours, links, browsers used, all this type of data is also stored inside the firewall. Then the next is IP packet screening routers. It means packet filtering gateway. Not only it looks at can it route, but should it selectively routes or blocks packets based on rules. It is based on protocols, destinations known as source IP addresses. Next is hardened firewall host. It is a hardware type of firewall. It halts unauthorized users. That means whenever an unauthorized user tries to access your system, it will halt your system. That means your system will be terminated. Then it concentrates on security, hides internal system names, centralizes and simplifies network management. Last one is proxy server. It is a software type of firewall. It deals with external server requests on behalf of internal clients. It may limit certain HTTP methods, for example CGI or Java applets. So, whenever you are having a proxy server on a particular system, at that system you won't be able to run CGI, that is common graphic interface, or Java applets won't be running on that particular system. The common solutions to all these problems are screened host. In this, as you can see from the diagram, there is internet and there is firewall screening router, then there are number of systems attached to internal network. Now, in this screened host, the host attached to internal network using separate router. Then internal host is only internal system that net host can connect to. All the host will be connecting to internal system only. Packet filtering configuration determines if internal host may connect to other external hosts. So, through packet filtering configuration, you will be able to determine that the internal host is able to connect to other external hosts or not. Another is firewall architectures. It is a dual homed host. In it, we have two network interfaces. One communicates externally and one communicates internally. There is no direct communication internal to external hosts. As you can say, see from the diagram, there is a real server, then there is a proxy server in which dual hosts are there, and there is a proxy client or internal host, and number of systems are attached to dual homed host. So in this manner you can have the firewall architecture in dual homed host. Then the next is screened subnet architecture. In it, an extra layer of security over screened host is placed. The perimeter network further isolates the internal network from the internet. There is one external router which is known as access router. Then there is internal best-in host, for example email, FTP and DNS. Then there would be a perimeter network and there would be internal network and internal router as well. Other variation for the proxy servers are multiple bastions hosts. Its performance redundancy need to separate data and servers. For example, Usenet, SMNP, DNS and FTP, World Wide Web. Then merge interior and exterior routers. Then there would be sufficient capability to specify inbound and outbound filters. Usually it is on the perimeter network only. Then the next is merge bastion host and exterior router. Use multiple exterior routers, multiple connections to internet or internet plus other sites will be available. Multiple perimeter nets, redundancy and privacy will be a problem. Then these type of solutions are not recommended that we are going to discuss now. First is merging bastion host and interior router, because breach of host leaves access to internal net. If your host is breached, that means your host is terminated, then one unauthorized person will be able to access the internal network. Then using multiple interior routers is also not feasible, because routing software could decide fastest way to another internal system is via the perimeter net, and difficult to keep multiple interior routers configured correctly. Most important and complex set of packet filters may need to use multiples to resolve performance bottlenecks or separate internal networks. So all these both are not recommended for a network security. Now what is the future of firewalls? There would be third generation firewalls. These are combined features of packet filtering and proxy systems, because a simple firewall only filters the packets that are coming in or out or your network, and in third generation firewalls you will be combining packet filtering and proxy systems both. Client and server applications with native support for proxied environments. Then dynamic packet filtering, packet rules modified on the fly in response to triggers. Underlying internet protocols undergoing revision, that is IPv4, that is Internet Protocol version 6. Then the next way to make your network secure is cryptography. Basically what is cryptography? And the learning objectives in this topics would be identify requirements for secure communication, discuss cryptographic techniques, define crypto systems and evaluate current encryption methods, then review digital signatures standards, discuss challenges of key management, review other security options and trust. So all these topics are under cryptography. Now what is cryptography? Basically we have to encrypt your information while we are transferring it over the network in order to make it secure, so that an unauthorized person cannot access your data. Even if they are able to access your data, they cannot understand your information. So this is the basic need. Why do we need to use cryptography while using internet? For any network transaction, there are three compulsory things. First is privacy, then second is confidentiality, and third is integrity. For reliable secure communication, authentication, we are who we say we are. That means an originality should be maintained. Then second is certification, guarantee by third party that we are what we say we are. Confirmation, digital receipt of transaction one needs to provide the digital receipt of a particular transaction when it is performed. Non-repudiation, binding agreement, digital proof of the transaction. Then last is encryption. For all of the above, encoded passage of information over open networks. Then now next are the cryptographic techniques. What are the various cryptographic techniques available that we can use while transferring our data over the network? First of all is secret writing or cryptic symbolization. Technique is encryption algorithm of crypto systems. It defines a pair of data transformations, encryption and decryption. In encryption, plain text is changed to ciphertext. Both use keys, seemingly random string. Key length is number of bits dependent upon crypto systems. So, this is the cryptographic technique. In this encryption, plain text is changed to ciphertext, and in decryption again the ciphertext is changed to plain text. Now, this is an example of encryption crypto systems. There is a symmetric encryption. It is known as private key systems as well, in which same key is used for encryption and the similar key is used for decryption of your data. DES, that is data encryption standards, it is a 56-bit key. It is vulnerable to exhaustive key search, that is 2 raised to power 56 possibilities. New standards are in process. As you can see from the diagram, first of all there would be plain text that we want to transfer over the network. Then by using private key you will encrypt that plain text, and then it will be changed to ciphertext, and by using the same key you will decrypt that text again and it will change to the plain text after that. This is the way how encryption crypto systems work. This is the working of symmetric encryption, in which only one key is used to encrypt the data and the same key is used to decrypt the data which is being transferred over the network. Now, another is asymmetric encryption. It is known as public key systems. In it there is a pair of keys. One key is used to encrypt the data and another key is used to decrypt the data. In 1976, Stanford development. Encryption mode is public key to private key. Authentication mode, private key to public key. Crypto systems operating both way called reversible. 1978 RSA, that is Rivas-Shamir algorithm. Reversible crypto system was developed. It was based upon multiplication of two prime numbers, which is possible to crack via large computer resources. In 1994, 429-bit code cracked by scientific collaboration after 17 years. It requires continual updating of modulus to protect JAWS tech. This is the history of asymmetric systems. Then the next is digital signature standards. Accompanies a digital encoded message. It verifies originator of message, it assures message is not modified, and it satisfies non-repudiation requirement. So, why do we use digital signature? They work like other signatures that we do on the papers. It simply verifies the originator of the message, that the message which is user is getting is originated from the right person only, and it also ensures that message is not modified while it was over the network. It also satisfies non-repudiation requirement. As you can see from the diagram, there would be plain text first of all, then by using the sender's private key it will be converted to it will be signed, then the plain text, with plain text there would be signatures also, and after the receiver, first of all the receiver will be verifying the data which he is getting, and after that after being verified then only it will be converted to plain text, otherwise the message will be simply discarded by the receiver. Now, what are the digital key management techniques? First of all, life cycle management, that is crypto period. Generation and registration, that means the generation of the key, and it should also be registered as well. There are random numbers for that. Distribution and availability, to what sort of persons the key should be distributed and to what sort of person it should be available. Key backup, recovery and key escrow, there should also always be maintained the backup for the key and recovery in case it is destroyed. Then replacement or update, replacement criteria should also be available. Protection against disclosure, the protection against disclosure should also be maintained. Termination or archival, confidentiality, archived information must be accessible after key retirement. Once the key is retired, it should be either terminated or it should or be archived in the organization. Other security methods are authentication protocols, which are built into communication protocol. First of all is transformed password. It is one-way function. The challenges are response, random value, required sent, received and sent, timestamp, synchronized clocks, one-time password, different variant each login, zero knowledge technique, that is interactive proof, address based authentication, it involves network addresses, personal tokens, they involved hardware and smart cards, biometrics, they involve fingerprint, voice print or handwriting only. So these are other security methods which can be used in order to make your network secure. Next is Kerberos. These are complete authentication system, MIT. DES Symmetric cryptography is used. Then online authentication servers are used. Host servers and clients share symmetric keys. That means there would be only one key to encrypt and same key to decrypt the data. Client requests a ticket, sends to receiver. Ticket interpreted only by the correct server. Session key is generated by authentication server after successful exchange. Authentication service, ticket granting service, client server, authentication exchange takes place in Kerberos. Then what is internet security? Basically there are three levels for internet security. First is at the network level, then application level, and then is system level. Network level is data packet integrity in transit. It involves authentication, confidentiality and access controls. Then IP layer, headers plus data is equal to IP datagram, not inherently secure, IP spoofing attacks, software false source addresses, authentication headers, integrity check values to indicate source and transit integrity of datagram, security association, security parameter index. Packet encryption encapsulating security payload provides confidentiality plus integrity. Then we can use algorithms, tunnel mode encryption, transport mode encryption, data will be encrypted. Key management, no single standard, host oriented, all users share same association and key. Potential for decrypt another's messages, user oriented, user has one or more association and keys. Lower risk, superior method, firewalls, screening routers, proxy servers, perimeter networks. Then there can be virtual private networks, secure groups of network sites using INET backbone, that is IP tunneling or IP firewalls. Messaging, special security needs above network measures, it includes email, mail enabled applications, writer to reader protection via user agent, message transfer agents, that is MTAs, message transfer backbone, originating and delivering, to whom from where they are originating and from to whom they are being delivered. Then basic message protection services, for example message origin authentication, content integrity, content confidentiality, non-repudiation of origin, enhanced message protection services, confirmation services, proof of delivery and submission, non-repudiation of delivery and submission. Others can be security labeling service. Then the internet security in messaging, secure messaging protocols are available, privacy enhanced mail, basic services. It wraps itself around standard mail message. Then there is MIME security multi-parts, multi-purpose internet extensions. It is the full form of MIME. Supports structuring of message body. Different body parts are text, image and audio, etc. 1995 specifications, security multi-parts for MIME, MIME object security